So Wiser User is a 2-year project, and it has a diverse team across science, social science, communities and boundary agencies. So we have the Met services from South Africa, Mozambique and Zambia, researchers in the UK and Finland and South Africa, and then we're working with communities in cities in Zambia, South Africa and Mozambique. I think one unique aspect of User is how it brings those groups together. The project is working from the user needs through the operational forecasting into the science. Every year we're coming together in what we call a forecast testbed, which brings together the users and the forecasters and the researchers to learn from each other. We're still on a really steep learning curve. It's been fascinating to see the opportunities that we now have. We've got new scientific products from artificial intelligence and machine learning that we're seeing scientific skill and value from. A lot of these techniques are new to the forecasters, so we're building the forecast capacity in these countries. But we're also looking at things like how these forecasts can be sustained long term and showing that the economic benefit far outweighs the cost of delivery of the services.
And at this desk or this station, we are doing synoptic 3-day forecasts. So generally what we look at, we always begin with a satellite so that we can appreciate what is occurring at that particular moment. So this is a satellite, and it will indicate to us where we've got cloudy weather, where we have storms occurring now, and then when we play it, we see how the storms have been moving.
This is the nowcasting table, and we're looking at now producing nowcasts for the next 2 hours and for the next 6 hours. This is impact-based nowcasting, so we want to know which areas would have rainfall and which areas would particularly have rainfall that will cause an impact to people, life and property.
So this is the evaluation table, and here is where we take the nowcast from yesterday or from earlier in the day, and we compare it to the best available observations we have for the area that was given the warning, and we assess whether that nowcast was successful or maybe was a false alarm or maybe too severe.
The testbed is a hands-on activity. You are taking the theory into practice. So you have the scientist coming together with the user, co-producing the forecast, testing it, and giving out a feedback. So it's go through the whole value of chain. So from observation, from forecasting, from packaging the information, communicating it in various ways, using the information they have developed with the scientists, but at the same time, we analyze if the decision was useful to them. Did the information make a difference?
I've seen a great difference, because the first testbed, we are just having it for the first time in our country. It was a learning phase, and immediately they see severe weather happening in the country, specifically the project area Kanyama. The forecasters were issuing what we're calling intensive nowcasting events. So there is a big difference, because now our forecasters, they're experts in producing these nowcasts.
Now it's very clear that the forecast services in the 3 countries have the skills and have the products they need to deliver the services. And those services have value to people on the ground. They're not just reliable predictions of rainfall, that people can actually use that information to make decisions. So the key thing now is those services are sustained long term, and that means that the metro services have to have the money ultimately to sustain them. But we know that the benefits far outweigh the costs. The exact mechanism probably will vary between the countries, but ultimately we hope that the forecast can be free to the poorest users and perhaps subsidised by the richer sectors such as aviation, who will have a willingness and ability to pay for bespoke forecasts. In the future, the vision of the UN's early warning for all is at the heart of the project. So everyone in the world ultimately needs access to reliable early warning of severe weather. For us in this project, that's about storm warnings in Southern Africa, and building on this project to distribute that across the whole of Southern Africa and indeed Africa. But critically as well, it's important that the solutions are developed in Africa to provide solutions for Africa. And as I said, machine learning provides new opportunities for that. And then those forecasts can be developed for the sectors that need them to address their local needs.